Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class, I will teach you the laws of motion, one part, Newton's first law. Student, in this previous class, that is class kinematics, motion in 1D or 2D, we have learned about the motion of the body. That is different equation of the motion, path of the equation of motion, and how velocity varies with time, acceleration varies with time, what is the relation between velocity, acceleration, etc, etc. Now today in this class we learn about the cause behind this motion. Newton's wrote his three laws and also different major laws, that is gravitation law, fluid mechanics law, and all the major laws related to the planetary motions in his famous book Principia Mathematica. Now today I will teach about the Newton's first law. This is theory class. No mathematics and no numericals and derivations will be discussed in this class. So some concept I will discuss. Now let's start about the class. What is the force? In this chapter we learn about the definition of the force and not measurement of the force. Measurement of the force is derived from the Newton's second law. Now in first law we just learn about the definition of force. What is the first law? Everybody continues its states of rest of uniform motion in a straight line unless compelled by an external force to change its state. That is, if a body is at rest, then it is always to be rest unless an external force applies on it, and if the body moves in a straight line always, then it will move continue unless an external force is applied on it. This is the first law. Everybody continues its state of rest of uniform motion in a straight line unless compelled by an external force to change its state. Now what is the definition of force? From this we get force. What is force? Force is a factor which can change the state of object. Force is a factor which can change the state of object. That is, a object is here. Now the object or body is at rest. Now a factor, a quantity which cause its change of rest, that is the factor which cause which moves the body is the force. So we define force. Force is the pull or push which change or tends to change the state of rest or uniform motion. Now what is the effect of force? Suppose a body is at rest. If the force is applied, then its speed will change, or a body moves with a constant velocity. Now if the force is applied, then velocity changes or speed changes. So what is the cause of the forces? What is the effect of forces? Now the velocity changes, velocity or speed changes. And second cause, the body moves in this direction, so a force is applied in this direction. Now its direction maybe changes, so the direction of motion of body also changes. And third, both speed and direction changes. Both speed and direction may be changes. So these are the effect of the force on the body. That is, if a force is applied on the body, then its speed may be changed, its direction of the motion may be changed. Both speed and direction both may be changed. So these are the effect of the force on the body. Now what is the inertia of the body? Inertia is the inherent property of a material. What is inertia? Inertia is the inherent property of material body by virtue of which it resists any change of state of rest or of uniform motion. Now inertia is a physical quantity. It is not measured, but inertia of a body is proportional to mass of the body. More mass means more inertia. Now there are three types of inertia. First, inertia of rest. It is the inertia of rest definition. It is the inability of a body to change its state of rest by itself. Inertia of rest. What is the example of inertia of rest? Suppose a bus or train start to move suddenly. Now the man inside the train or bus leans backward because due to inertia motion, due to inertia motion, the feet which is contact in the bus or train moves with the bus immediately, but upper part of the body due to inertia motion tends to remain in its original position. So the man leans backward. This is the example of inertia of rest. Suppose a glass is present here, or a container or cup is present, and a thick paper is on the cup. Now a coin, suppose a coin is present here. This is smooth paper. Now very smooth paper. Now if the by hand, then this slips forward, this slips forward, and the coin drop this cup. Now because the motion is transmitted here, not transmitted to the coin, because then due to inertia motion the coin tends to remain in its position. So it moves, and coin due to inertia motion, inertia of rest, due to inertia of rest falls in this cup. So this is the example of inertia of rest. Another example of inertia of rest is if a blanket is hanging vertically, and this blanket is beaten by stick, then the dust inside the blanket fly away, because due to inertia of rest the dust tends to remain in its position and the blanket moves, so the dust now falls under gravity. So this is an example of inertia of rest. Now what is the inertia motion? Inertia motion, it is the inability of body to change its state of uniform motion by itself. Inability of body to change its state of uniform motion. That is, if a body is already in motion, then it is the inability of the body. So body does not tend to change its motion of its uniform motion by itself. So what is the, suppose a body in the ground moves with uniform velocity. After some time, according to the Newton's first law, the body moves continue for eternal, but practical what we see, the body stop after some time. So is the violation of Newton's first law occurs? So this is not, because here external force is actually friction force. Here external force is actually friction force. Friction force is the external force. So here Newton's first law is not violated. Newton's first law states that if no external force is applied, then body tends to remain its motion always same. But here external force is frictional force. Due to friction, the body stop after some time. Part is inertia of direction. It is the inability of a body to change its direction of motion by itself. When a bus moving with a uniform velocity suddenly stops, then the passenger inside the bus moves forward. This is because due to inertia of motion, when the bus stops, then the feet which is contact with the bus suddenly stops, but upper part of the body which tends to remain in its motion. So the man moves forward. Now another example is that if a passenger inside the moving train throws a ball upward, then after some time the ball return in its head. Because due to inertia motion, the ball which is, when it is projected upward, gets some horizontal velocity, which is the velocity of the train. Now the vertical acceleration has no effect. Vertical acceleration has no effect on the horizontal velocity. So the ball, and due to inertia motion, the ball and man moves horizontally same with together, and so after some time the ball return in its head. So these are the example of inertia motion. Now what is the example of direction of inertia of direction? When a bus moving in a straight line takes sharp turn towards right, then the passenger inside the bus lean towards left. This is because due to inertia of direction, the passenger remained its motion, its direction in a straight line, but the bus take turns right, so the man or passenger inside the bus turn towards the left. So these are the example of direction. Or if a knife is sharp in a rotating wheel, then the spark of fire coming from the wheel moves in tangentially. So these are the example of inertia of direction. We know the to specify a position of an object, a origin and a coordinate system are required. Now if the frame of reference is attached with a stationary ground or with a moving object, then that is non-accelerated frame is called inertial frame of reference. Inertial frame of reference means the frame of reference which has no acceleration, that is it is either rest or it is moving with a uniform velocity. Now that is called inertial frame of reference, which is also called non-accelerated frame of reference. Now Newton's law is applicable on this inertial frame of reference. Newton, all the laws, three laws are applicable only inertial frame of reference. Now what is the non-inertial frame of reference? If a frame of reference attached to an accelerated object, that is accelerated frame of reference is called non-inertial frame of reference, and Newton's law is not applicable directly here. So two type of reference frame are present. Now what is Newton's first law state that if a body moves in a straight line with uniform velocity, then it is not stopped until an external force is applied on it. Now external force means not a single force. Suppose there are many force act, and the body also moving. There are many force act on the body, but the body is still moving with a constant velocity. So here Newton's first law is not violating, because if the force resultant of all the forces, if the resultant of all the forces is 0, then the body continues his motion of the body. Condition is that not a single force act, many forces act, but if the resultant of all the force is 0, then Newton's first law is applicable, because resultant of all the force is 0. Fx summation of all the force is 0. This is called equilibrium of the body. Equilibrium of the body, that is resultant of all the force acting on it is 0. Now here on this theory, here a MCQ is here is MCQ. A body is at rest, which option is correct? No force is acting on it. No force is acting on it. Body is very massive, and therefore it is at rest. There may be many forces, but their net effective is 0. None of these. A body is at rest. Which option is correct? So option will be, I have discussed already. Option will be C. There may be many forces, but their net effective force is 0. This is the correct. Student, this is the end of the class. To get my IIT and NEET videos, subscribe my channel. Okay, thank you.